Welcome back to my YouTube channel. Today, I would like us to talk about logarithms. Here, we want to see how we can tackle questions on logarithms with confidence. I am going to be talking to you about some laws of logarithms, which I can assure you that if you know these logarithms laws and you apply them in the various questions that will be coming out to you, you can be rest assured that you will be able to tackle 90% of your questions with confidence that you will get them right. So, to cut the long story short, I would like you to pay rapt attention to what I will be dishing out to you, the laws, how I'm going to explain them, and how we are going to apply them. Don't forget to also like this video, share it, and also subscribe to the YouTube channel so that whenever I upload videos like this, you will get the notification. Alright, now let us get into the business. We want to talk about logarithms. Now, I have found out that in solving questions on logarithm, there are some knowledge that we ought to have known before we can embark on the knowledge about logarithms. What are this knowledge? If you want to understand logarithm very well and you want to be able to solve questions on logarithms very well, you need to know what we call indices. This is because indices and logarithms are very related. You can't learn them independently. You can't learn logarithms and not learn indices. And you can't learn indices and not at the same time learn logarithms. You need to learn the both of them. So if you want to understand logarithms well, you need knowledge about indices. And what is indices? Indices is just powers. That's what it means. It means powers. Powers of numbers. Now, in under indices, you learn about how you apply some laws of indices. Like when you see indices, how should you treat them? That is basically what we talk about in indices. And now you have to have that knowledge, basic knowledge about indices, before you will be able to understand logarithms very well. The second thing you need to understand is factors and composites. Factors and composites. What are factors? When you have a number, the other numbers that can divide that number without remainder are the ones we call the factors of that number. E.g., if we take a number such as 10, numbers that can divide 10 without remainder are 1, 2, 5, and 10. All these numbers can divide 10 without remainder. They are the factors of 10. Can I divide 10 by 3? Yes, of course I can, but it will remain 1. Because it has a remainder of 1, then 3 is not a factor of 10. That is basically what factors mean. Any number that divides another and is giving you a remainder, leaving a remainder out for you, is not a factor of that number. Then what are composites? Composite is the opposite of prime numbers. What are prime numbers? Prime numbers are the numbers that they only have two factors, which are 1 and the number itself. Aside 1 and the number itself, any other number you use to divide them will always yield a remainder. Example of these numbers are 2. 2 is the first number that is prime, followed by 3, followed by 5, followed by 7. Is 9 a prime number? The answer is no. Because aside 1 and 9 that can divide 9 without remainder, 3 can also divide 9 without remainder. And do you remember what we said prime numbers are? Prime numbers are the numbers that have only two factors. And these two factors are that number itself and 1. And this is why 9 is not a prime number. Is 15 a prime number? The answer is no. Because 15 can be divided by 1, 15. It can also be divided by 3 and 5. And because it can be divided by 3 and 5, in addition to 1 and 15, that it's the same number, then we say 15 is not a prime number. If 15 were a prime number, it will have only two factors and they will be 1 and 15. Is 17 a prime number? Yes. Because aside 1 and 17, no other number can divide them. So if you want to work on this and you want to know prime numbers well, you can just list out all these numbers and start looking at them. Any number that you see that cannot be divided exactly aside 1 and the number itself, we say these numbers are prime numbers. Then what are composites? Composites are numbers that are not prime numbers. Composites are numbers that are not what? That are not prime numbers. What am I saying? These are the numbers that aside 1 and the number itself, there are also some other numbers that can divide it. So is 4 a composite? Yes, it is, because aside for 1 and 4, 2 can also divide 4 without remainder. This is the idea of factors and composites. The next thing you need to know is the conversion of decimals to fractions. You need to know how to convert decimal fractions to normal fractions, fractions of numerator and denominators. You need to know how to do this as well, because it is very, very important. You can find them in solving logarithms. So when you see this kind of numbers, you will be able to deal with them with confidence. And the last thing you need to learn about is solving equations. You also need to know how to solve equations. What kind of equations are we talking about? And basically for our level, we have two basic types of equations, which are the simple linear equations and the quadratic equations. You need the idea of solving these kinds of equations because you will come across them in solving logarithms. But enough of all this discussion. Let us now talk about the laws of logarithms. We learn what they are, and after that we are also going to solve examples on them so that you'll be able to deal with them confidently. I believe by the time we finish these lessons, you will be able to confidently tackle logarithm questions. So, I urge you to come along, but however, do not forget to like, share, and subscribe to this channel so that you can get updates anytime I drop new videos. Alright, let's go on to the next part. What are the laws of logarithms we need to know? Now, the laws of logarithm I will be discussing with you, they are about 7 in numbers. But out of these 7, you see the first 5 I'll be giving you, I urge you to please pay attention to them. You see the remaining 2 are very important as well. Yes, they are very important as well. Anybody can bring out laws of logarithm. The more you solve logarithms and you understand it, and you see the relationship between logarithms and indices, you also can also bring out some laws of logarithm that you have seen that this is the way it works. So I am going to show you 7 of them, but the first one I'll be showing you is the relationship between indices and logarithms. The relationship between what? Indices and logarithm. How are indices and logarithm related? We want to see a law that tells us how we can transform indices to logarithms and how we can also transform logarithms back to indices. Now, let's look at law 1. This is law 1. Law 1 says that if A is equal to b to the power of x. That is, this is a number, and I can write this number as another number to a particular power. Then, if a number can be written in this form, I can write this as the logarithm of this number to this base is x. The logarithm of a to the base of b is x. Now, take note of something here. In this place, this b is the base of this number, and this one is the power of this. So this means that the b never changes its name as the base. So the logarithm of a, the logarithm of this number to the base of b is that power of x, or the exponent x. Now, what we are trying to say is, if you have indices like this, you can transform it to this logarithm, and if you have this, you can also transform it back to indices. Now, let us see how this is done so that you will be able to follow through what we are talking about. You see all these ones that we have written up here? I know they may look somehow, but let's use some examples to explain what we are talking about. Now, look at this example. They said, write the following in logarithmic forms. Write the following in logarithmic forms. How do we write this in logarithm forms? Now, this is what I'm going to do. I'm going to write it that it is going to imply the logarithm of this number 8 to the base of this 2. You can see that the base here is 2. So the base of 2 is equal to 3. That is what you want to do. What about this? From this example we have done, I believe you also can tell me that this is going to become the logarithm of 27 to the base of 3 is equal to 3, the exponent. What about this? I believe you will also agree with me that this is going to become the logarithm of 32. Logarithm of 32 to the base of 2 equals 5. And lastly, this one. We know that 625 can be written as 5 to the power of 4. Then we can write that the logarithm of 625 to the base of 5 is equal to 4. So you are simply telling us that if I want to write 625 as a number whose base is going to be 5, then the power has to be 4. That is what it simply means. So this is how you can transform the indices to logarithm. We are not done with these examples. I want to solve another set of examples on this same law. Stay tuned. Let's take a look at another question, which we can still apply this law to solve on logarithm. The question says, if the logarithm of 81 to the base of 3 is x, then what is this x? I want to recall this particular law. The law tells me that if I have the logarithm of 81 to the base of 3 and we said it is equal to x, we said we can transform this back to this. So that means I can simply write this as saying 81 is going to be equal to 3 to the power of x. So which means what I need now is just to ask myself, what power of 3 will give us 81? We remember something, that 81 itself is 3 to the power of 4. What I meant is that when you do 3 times 3 times 3 times 3, which is 4 times. 3 times 3, that is 9. 9 times 3, 27. And 27 times 3 is 81. So which means 3 to the power of 4 is 81. Then I change this 81 to 3 to the power of 4, and I equate it to my right hand side. You will see that what you have on the left hand side and the right hand side are similar. 3 to the power of 4 equals 3 to the power of x. That means this 4 has to be equal to x. That means 4 equals x. So, or x equals 4. And that is what it is. Can you see how I applied the formula, the law, to solve the question? This is how we do it. Let us solve one more question on this law. Let us look at another question on this same law. If the logarithm of a to the base of 10 is equal to 4, what is this a standing for? A is that number. If we take the logarithm of this number to the base of 10, we get 4. How do we solve this problem? This problem looks like what I have here. I can convert it back to indices. And what would that be? If the logarithm of a to the base of 10 equals 4, we already said this can now be written as a is equal to what? To 10, which is the base of 4. And what is 10 to the power of 4? That means a is equal to 10 times 10 times 10 times 10. And this gives us 10,000. So what this means is that the logarithm of 10,000 to the base of 10 equals 4. And that is how it is done. Alright, looking at the set of examples that we have answered here, I believe if you find questions on this law, you will find it easier to do. Then if that is the case, let me give you some practice questions to work on to drive home whether you have learned something under this law. take note of the next set of questions you would like to try. Now, let us see some questions I would like you to work on. So, with what we have learned so far under the first law of logarithms, I believe you'll be able to answer these two questions following my examples. Now, you want to first convert all these questions, A, B, C, and D. You want to convert them to the logarithm forms. You will see that their forms are already in this way. So you want to transform them to this. Now, the second question is, if you have the logarithm of 144 to the base of 12 equals to y, then what is this number going to be? We have answered the question like that in the examples. So I would like you to get what y is. Then question 3. If the logarithm of x to the base of 1 over 3 is 4, then what is x itself? This number, what is it standing for? I would like you to find what that is. Let's talk about the second law now. This is what the second law says. The second law says that the logarithm of a particular number to a base added to the logarithm of another number to the same base just as the first, the same base just as the first. The addition of these two is the same as multiplying this and this together, the logarithm of this times this to the base of x. Some people call this law the addition law of logarithm. Some call it the multiplication law of logarithm. What it simply implies is that if you wish, you can transform from this way to this. And you can also transform this back to this. Now, to drive home what I'm trying to show you here, let me take some examples to show you how we apply these laws. Now, let's take some examples. Then I am going to emphasize on some important key points. And what are those key points? This is the base of the two numbers that you are trying to add. The base of the two numbers you are trying to add. You must ensure that the same base is what you have for the two before you apply this law. Now, let's go on. Take for instance, this is question 1. I have the logarithm of 5 to the base of 2 added to the logarithm of 4 to the base of 2. When I see a question like this, I know what I want to do. The next thing I'm going to do is I'll just write this is equal to the logarithm of 5 times 4. 5 times 4 to the base of 2. And this will give me the logarithm of 20 to the base of 2. This is basically what I'm expected to do. Let's take another question. Question 2. What is the logarithm of 9 to the base of 3 added to the logarithm of 9 to the base of 3? This is going to become the logarithm of 9 times 9 to the base of 3. And that is the logarithm of 81 to the base of 3. Now, there is still something I can do to this, but when we get to that law, I will show you what you are supposed to do. Why we should not leave this answer the way it is. Now, let's look at this last question for this example. What if I was given log 100 base, let's say base 5, 100 base 5. It could be any base. It could be base 10, base E, base whatever. We don't care. Now, what I want to do here is this. You want to see the way I'm going to split this particular one to come and become something like this. You guys would not forget that 100 can be written as 4 times 25. You also know to the base of 5. You also know that this same 100 can be written as the logarithm of 10 times 10 to base 5 because of we are keeping the base. So what we just did here is that we are trying to express 100 as multiples. If you wish, you can write 100 as multiples of 3, 10, 5 numbers. As long as you keep multiplying those numbers and you get 10, you can keep writing it that way. If I also wish, I can write this as the logarithm of 2 multiplied by 50 to the base of 5. So what I've simply done to all these cases is that I am trying to show you that it is still the same thing I am trying to do, because I want to transform this into its composite. Then what is going to happen now? Now, based on the law that we have, if we have something like this, then we can say this is the same as the logarithm of 4 to the base of 5 plus the logarithm of 25 to the base of 5. This is one way whereby this is the same as what you have here. Let me transform the second one. This second one too can be written as the logarithm of 10 to the base of 5 plus the logarithm of the same 10 to the base of 5. And look at this last one. We can transform it to the logarithm of 2 to the base of 5 plus the logarithm of 50 to the base of 5. I hope you can now see what we just have to do. Anytime we see we need to add two logarithms together, as long as they have the same basis, the same base is what they have, then all you just have to do is just multiply the two numbers and don't forget to write that base. So if you wish, you can transform from this way to this way, or you transform from here to here, but just have it at the back of your mind that anytime you want to add logarithms, this is what you just have to do. Now, with this little explanation on the second law, let us take the third law, which looks more like it. And as we take that law, we are now going to see how we can use these two laws in solving some questions together with the first law I have given to you. Now, stay tuned and let us see the third law. You should not forget this law as well. Now, what is the third law telling us? The third law is telling us that the logarithm of a to the base of x minus the logarithm of b to the base of x. Remember that in the second law we just discussed, we were working with addition. Now we are working with subtraction. If you are asked to subtract two logarithms that they have the same base, what are you going to do? All you have to do is, instead of you multiplying like before, what you want to do now is you want to divide. You say a divided by b. So the logarithm of a to base x minus the logarithm of b to base x is equal to the logarithm of a divided by b to the base of x. Now let us take some examples to show you what this law is doing and how we apply it. And do not forget as well that you can transform this to this or transform this back to this. Now let's look at some examples. Now, supposing we have the first example to be the logarithm of 20 to the base of 2 minus the logarithm of 4 to the base of 2. What is going to be the final answer? Then this is going to become the logarithm of 20 divided by 4 to the base of 2. And this will give us the logarithm of 5 to the base of 2. Final answer. Let's look at another one. Number 2. What is the logarithm of 9 to the base of 3 minus the logarithm of 27 to the base of 3? This is going to become the logarithm of 9, the first number, divided by 27 to the base of 3. And what is this going to give us? 9 in here is 1, 9 goes here is 3. Which means we have the logarithm of 1 over 3 to the base of 3. What if I have this? What is if I wish to write the logarithm of 1 over 8 in base 2? You will see that this 1 over 8 is the same as saying the logarithm of 1 divided by 8 in base 2. And what this implies in logarithm form is that I can rewrite this. I can rewrite this to be the logarithm of 1 to the base of 2 minus the logarithm of 8 to the base of 2. I hope you can see this clearly. Now, this answer we have just, all these answers we have just written here, they are showing us how we apply this particular law. You can see that it is a very simple thing. This is what mathematicians understand, that anytime they are dealing with problems like this, they just have to transform the ones that look like this to this, or they transform the ones that look like this to this, and just for them to be able to find a way to solve the question they are given. And this is what we need. Let us now go on to the fourth law. This is the fourth law you are seeing on the board. And the law says that the logarithm of a particular number with a particular power. Take note, this number has a power p and the base is x. This law tells us that we can transform the logarithm of number that looks like this to this. So you can turn from this to this, or you turn from this back to this. Now let us see the example that tells us what this law is simply trying to let us know. Examples. If I have the logarithm, number one example, the logarithm of 5 to the power of 3 to base 2 is the same as writing this power first, 3, write your log, write your 5, and keep your 2 here. I hope you can see that. Another example is this. If I have the logarithm of 9 to the base of 3, remember that 9 can be written as 3 to the power of 2. Then I have the logarithm of 3 to power 2. Then the base is what? Is 3. Now, what this means now is that since this is not looking like the law, we can then transform this to writing 2 first, then the logarithm of 3 to base 3. Let me try another. What if I was given 1 over 2 logarithm of 9 to base 3? This means that if it is now looking like this form, where my p now is standing as 1 over 2, I have the logarithm of 9 to the base of 3. You can see they are similar to this. Then I can transform from this form to this form. Then this is going to become the logarithm of 9 to the power of 1 over 2 to the base of 3. Now, this is an indices, an index. So there is a law of indices that tells me what I can do to this. The law of indices says that the logarithm of 9 to the power of 1 over 2 is the same as saying the square root of 9 to the base of 3. And this is going to become the logarithm of 3. Since 3 is the square root of 9, then base 3. Please, kindly do not forget that in this case, we are talking about the positive root of whatever root we are talking about, not the negative root. Now, I told you something similar in the past about when we were discussing law 2, that there are some numbers that we don't leave the way, there are some logarithms that we don't leave the way they are. And that is the truth. The next law will tell us why I said we should not leave them the way they are. But however, you have seen it with this example that if you are given a logarithm that looks like this, you can turn it to this, or you turn from this to this before you start simplifying. Now let's look at the law 5. This law 5 will now tell us what we need to do to some of the questions that we have here. Questions like 2 log 3 base 3, log 3 base 3. What can we transform them to? Let us take a look at what we can do to them. Law 5. This is law 5 you are seeing on the board. Law 5 says that the logarithm of a to the base of a is 1. Meanwhile, I will like to give a clause here that a is not equal to 0. A is not equal to 0. So what I'm saying is that log 0 base 0 is not equal to 1. So a cannot be a 0. So but any number apart from 0, and also remember that we are not talking about a negative number here as well, only positive numbers. So the logarithm of a number to the base of that same number is always equal to 1. And this is a very simple law that we can understand. Remember what I told you earlier on in law 1. as the relationship between logarithm and indices. I said if we have the logarithm of a number to a particular base and is equal to this, we said we can transform this to a being equal to b to the power of x. Do you remember that? And we can also transform from this to this. Now, if you take a look at this law, we have the logarithm of a to the base of a is equal to 1. Now, if I want to transform this, then I'll be saying this a can be written as this base to the power of 1. And is this true or not? Yes, it is true. And this is the reason why the logarithm of a number to the base of that same number is always equal to 1. Now, let us use this idea to give some examples on what we should have done to some numbers that we have done in the past. In fact, most times whenever we are solving questions on logarithm, you may eventually get to the stage whereby you must apply this law. And this is why I said the first 5 laws I'm going to give you are very, very important. You should not forget them because they help you to know what you should do when you are faced with some kind of logarithms. Now, let us go on to some examples on this and see how we are supposed to simplify them. From this law, we can now say the logarithm of 3 to the base of 3 is going to be 1 because the number and the base are the same. Now, for this one, you will see that I also have the logarithm of 7 to base 7. Now, this is the 5 in the front. What this simply means is more or less like me saying the logarithm, 5 times the logarithm of 7 to the base of 7. And from what we have seen in this law, what you have here is the same as 1. Then I can say what this is simply telling me is saying 5 times 1, and that is 5. So this whole thing here is the same as the value of 5. Let's look at this as well. Just as I have done earlier on, 3 over 2 log 2 base 2 is more or less like me saying 3 over 2 times the logarithm of 2 to the base of 2. And from what we have seen in this law, we know that logarithm of 2 to base 2 is surely 1. That means this expression is the same as saying 3 over 2 multiplied by 1, and that gives us 3 over 2, which is the same as 1.5, or 1 number 1 over 2. What is the logarithm of 10 to the base of 10? The answer is 1. What is the logarithm of e to the base of e? The correct answer is also 1. What is y log y base y? This is the same, just like what we have done earlier. It means y multiplied by the logarithm of y to the base of y. And we have stated here that the logarithm of y to the base of y is 1, which means what I imply is saying y times 1, and my final answer is y. And this is how to apply that particular law. So meanwhile, that means that every place where we see the logarithm of a number to the base of that number, we just want to equate that particular expression to 1. And that is how we do it. Now, let me give you the last 2 laws we want to talk about, which is law 6 and law 7. What would you do if you are given the logarithm of a number that has a base to a particular power? Take note here that the base of that logarithm is what is having this power. How do you deal with it? Now, you see this particular expression is the same or can be transformed to writing the reciprocal of this p, which is 1 over p, the logarithm of n to the base of x. Can you see what I transform this to? That is, take the power, write the reciprocal here, 1 over that thing. Then the logarithm of n, which is the number, to the base of x. This expression as well, we can apply law 4 to it. Remember that law tells us that whenever we have a number in the front of log, we can put the number as the power of this. And that implies that what I have here can also be written as the logarithm of n to the power of 1 over p to the base of x. So these are the 3 forms, these are the 2 forms you can transform this to. So which means if I wish, I can change this to this, or I change this to this. They are equivalent. You can just transform them from one form to another. Now let us take some examples that describes what we are talking about here. Some examples. Now let us assume that I was given a number, I was given a logarithm. They told me that the logarithm of 7 base 49. I looked at it and I felt something. Okay, I have been taught about law 5 that says that the logarithm of a number to the base of that number is equal to 1. Now how do I solve this? I thought of 49. I remember that, okay, this is this 7, but 49 can be written as 7 to the power of 2. 7 to the power of 2. And if I express it this way, this law tells me that I can then say 1 over 2, the logarithm of 7 to the base of 7. Wow! Logarithm of 7 to the base of 7. And I think I know what I can do to this log 7 base 7. We have read in the 5th law that this particular one can serve as 1, then this means I am having 1 over 2 multiplied by 1, because log 7 base 7 is 1. Then the final answer is 1 over 2. Can you see how we solve the question? Very simple. Let's take a look at another question. Number 2. I have the logarithm of 9 to the base of 3 to the power of 2. There are many ways I can solve this question, but I want to apply this particular law that I have given here to solve the question. I said this can now be equal to the logarithm. I want to use this expression now. That means I will say 9 to the power of 1 over 2 to the base of what? 3. Now, how do I simplify this? Don't forget that raised to the power of 1 over 2 implies the square root of 9. But this time around, I don't want to do that, which I can just do. I could just say the logarithm of the square root of 9 to the base of 3. And this will give me the logarithm of 3 to base 3, which is equal to 1. I could also say, okay, from here, the logarithm of 9 to the power of 1 over 2 base 3 is equal to the logarithm of 3 to the power of 2 to the base of 1 over 2 base 3. You will notice that what I did here is just to change this 9 to 3 to the power of 2. And there is a law of indices that tells me what I should do when I have power to another power. I just have to multiply. What is 2 times 1? That is 2. 2 divided by 2 is 1. So that means automatically this cancels this, and I'm left with log 3 base 3, which is also equal to 1. So what you just need to understand here is that anytime you have a base that has a power, or you are the one that wrote it in that form, you can transform this to this or this. Now let's take the last law on these lessons. Do not forget that I said there are many other laws, but for the sake of your examination, these 7 laws I'm giving you are very, very important that you should not forget them, especially law 1 to law 5. I hope you get that now. Now let's look at law 7. Law 7 states that the logarithm of a number to a base, this logarithm of this number to the base b can be written as the logarithm of a over the logarithm of b to the same base. I can write it as base 10. Most times we use base 10 to the base of 10. So we can transform this to this. What this implies is that, for example, if I have the logarithm of 15 to the base of 5, I can write it as the logarithm of 15 over the logarithm of 5. Always take note of this. For our level, anytime you see a logarithm that the base is not written, you always take the base as base 10. Always take the base as what? Base 10. So if I wish I could write the 10, if I wish I may not write the 10. I hope you take note of that. So you can write it in this form. If you also have the logarithm of 8 over the logarithm of 2, you can transform this to the logarithm of 8 to the base of 2. Then you can now apply some other laws that we have to solve or evaluate this question. So for the purpose of this class, let me just complete what you see here. Now this is going to become the logarithm of 2 to the power of 3 base 2, because I can write 8 as 2 to power 3. This is why it is very important that we know how we can transform numbers to indices. Now, there is a law of indices that tells me what I should do to a number with a power. In this case, it tells me that I can write this 3 in the front and write log 2 base 2. There is another law of logarithm that tells me what log 2 base 2 says, or what it implies, and that means we are simply saying 3 times 1. No doubt the solution to this question is 3. Now we have looked at all the laws of logarithm that I intend to give you, from law 1 to law 7. The first law says that if a is equal to what? B to the power of x, then we can express it as logarithm, that the logarithm of a to the base of b is equal to x. The second law is the law of addition, which says that the logarithm of a to the base of x plus the logarithm of b to the base of x is the same as you saying the logarithm of a times b to the base of x. The third law says that the logarithm of a to the base of x minus the logarithm of b to the base of x is equal to the logarithm of a divided by b to the base of x. I gave you the fourth law. I said the fourth law is the logarithm of n to the power of p base x. Then that means I can write p first and say p log n base x. Then law 5, I said the logarithm of a to base a is equal to 1, where a is not equal to 0. The law 6 is that the logarithm of n to the base of x to the power of p, I implied that we can rewrite this in two ways, by writing the reciprocal of that power of the base, which is 1 over p first, then the logarithm of n to the base of x. Or I say the logarithm of n to the power of 1 over p base x. And the last law I just gave you here is the logarithm of a to the base of b. And I said this can be written as the logarithm of a over the logarithm of b to the same base. And this same base for our level is always going to be 10. I hope you have learned something today. I have some questions I would like you to try, and there is going to be another video where we'll be answering questions from the past examinations and see the way we apply all these laws in solving questions on logarithms. No doubt you have learned something. I want to urge you to continue practicing mathematics, because the more you practice, the more you get it, and you end up seeing that mathematics is not as hard as we think it is. Don't forget to like, share and subscribe to my channel so that you can get updates immediately I drop videos like this. Thank you and enjoy your time.